Question 11. This is an integral question. You have to find I, which is integral 2 to 343 into x minus greatest integer function of x whole square dx. So this integral could be written as integral 2 to 3 x minus greatest integer function of x whole square dx plus integral 3 to 4 into same thing dx plus and so on till integral 342 to 343 and same thing dx. Now for this particular integral, let us make a substitution that t is equals to x minus 2. This implies x is equals to t plus 2. So you have integral 0 to 1 x becomes t plus 2 minus greatest integer function of t plus 2. And because t is equal to x minus 2 implies dt is equals to dx, so dt. So this is integral 0 to 1 t plus 2 minus t minus 2. So this minus 2 is simply thrown out of the greatest integer function into dt. So the 2 cancels out and this is simply integral 0 to 1 t minus t dt. Now let's come to the second part. In second part you can make a substitution s is equals to x minus 3. Then the integral becomes integral 0 to 1 t plus 3 s plus 3 minus greatest integer function of s plus 3 dt, which is equal to integral 0 to 1 s plus 3 minus greatest integer function of s minus 3 ds. Sorry, this should be ds. And the 3 cancels out, so you are left with integral 0 to 1 s minus s ds. So what will happen is that each part becomes the same. You can do separate different substitutions for each part. What you will be finally left with is 341 times. So this you will be getting 341 different integrals. So 341 times integral 0 to 1 t minus greatest integer function of t dt. Now this greatest integer function, whenever t value is between 0 to 1, is simply 0. So this is 341 times integral 0 to 1. So actually there should be a whole square everywhere. Whole square everywhere. And similarly we'll be having whole squares here as well. So simply t square into dt. And that is equal to 341 into integral t square dt is just 1 by 3. So 341 by 3. So that's your answer, which is your option C. So that's your answer.